So in this section 1.7 in your Foundations 10 textbook, starting on page 55, we're dealing with surface areas and volumes of composite objects. And to the right here you see that this is an example of a composite object. We have a rectangular prism and a cylinder. And they're kind of stuck together, right? And so this section is all about objects that are combinations of figures that we have talked about already, such as cylinders, prisms, pyramids, spheres, etc. Okay? And we're going to go through and what we're going to do is we're going to find the, let's see, in the textbook they talk about volume and surface area, so I guess we could do both, really. So let's find the volume of this. So this is, let's say this is number 8 here. Let's find the volume here of this figure. Okay, the volume. Now, volume is pretty straightforward because, pull this down a little bit. It's pretty straightforward because it's basically just the sum of the volumes of each figure. You don't have to worry about, overlap of, a side area or anything like that. That's going to come next. But volume is pretty easy. So if you consider this as, object number 1 and this is object number 2, what we need to do is we need to find the volume of object 1 and we need to add it to the volume of object 2, and that gives our volume total. Okay? Does it make sense? What doesn't make sense is why I wrote all uppercase letters except for that A. Okay? There we go. So, what is the volume formula for volume 1? You guys remember how to find the volume of a cylinder? It's just a prism, remember? It's a circular prism, right? So, you find the area of the base and multiply it by the height. So, we have pi r squared, that's the area of the base, times the height. And it's always a good idea to write out the formula at the beginning of your work like that. Part of the reason is so that you become familiar with the formula and you can memorize it easier. So if you write it out every time, it's something that you see a lot and you spend time writing it out and you just get more familiar with it. Okay? So I suggest you doing that every time. Is it wrong if you don't write this formula every time? No, but I would strongly suggest that. Okay, so pi we know is just a constant value that we'll just use our calculator to calculate. And r is the radius, and so here it's given as 4 feet. Now, you don't have to include your units in your work like this. Oftentimes the units just mess things up, like they just, it becomes really messy and just too much. So you don't have to use units, I don't require that. So r squared, radius squared, times the height, which is 8. We do have to keep in mind the units, so we'll just remember that for the end. Okay, so you get your calculator out here now. And you just go ahead and you plug that in. So we can do pi. Please use your pi button. Don't write 3.14. Okay, that is not precise enough. You need to use the whole decimal. If you can't find your pi button and you really don't want to use your pi button for some strange reason, you need to use the decimal at least 3.14159. At least that. Okay, but use your pi button is the best. And then times, 4 squared. So I would include the squared in the brackets just so there's no question. And then times 8. Okay, and plug that in. And that's 16 times 8 times 3.14159, so about 402. So let's write as many of these decimals as we can, 3 or 4 at least. So 402, 1, 2, 3, 9. 402.1239. And what's that going to be? That's going to be feet, cubed, right? Feet cubed, cubic feet. Okay? Is everyone okay with what we did there? Keep a lot of decimal places. Use your pi button, okay? Volume 2 is the this thing here. Now, the base, you could call this the base if you want, right? The thing that's on the bottom, is reasonable for the base. And then this is the height here then, right? And so the area of a rectangular prism is, of course, just area of the base times the height. So that's going to be length times width times height, right? length times width times height. Which, pretty easy, going to be 14 times 8 times 12. And as fast as you can on your calculator there, multiply those three together. And you get 1344. No decimal places or anything, right? So, and now you can add the two volumes together to get your volume total. So volume total is V1 plus V2, which is 402.1239 plus 1344. Okay, so here's your answer there on the calculator, and that's going to be your volume total. And so that's going to be, what was that again? 1746.12. 46.12, and that's going to be cubic feet or feet cubed. If you're wondering what decimal place to go to, just go to 2 decimal places. That's a good idea. Okay, everyone get that answer? Is that confirmed? Did I punch something in wrong, or are you guys okay with that? Does that look right? Because I want you guys to be doing the exact same thing that I'm doing as well. All right. Sometimes it happens that, oh, Mr. Maxwell's going to do everything up on the computer there, so I'm not going to type anything in my calculator. I'll just copy down what he does. I want you to get to know your calculator. Sounds dumb, but you wouldn't believe how many grade 12s right now don't know where their scientific notation button is, or don't know how to take the square root of something, or because they've never, they just aren't familiar with their calculator. So get familiar with your calculator. And B, if I type in something wrong here, and there's going to be a bunch of you that do it right, and so we'll know. Okay? Make sense? Okay. Any questions about this? Because I want to move on to surface area, and we'll use the same. We'll use the same thing here, the same diagram, and we'll do surface area. Okay. Let's see if I can do this. Copy. Nice. All right. So let's do surface area. Okay. Now, surface area is a bit trickier, and I'll tell you why. I mean, you can probably see this right now, but finding the area of the exposed surface on a composite object often requires you to consider the area of sort of the overlapped region. Okay? And you see this area right here, because that cylinder is plopped right on top of that prism, that there's a piece of the top of the prism that is not exposed anymore. That is not part of the surface area anymore, because it's covered up. So we only want to calculate the part of the object that's exposed. And in this case, if you want to think of it, exposed to the air, right? And so this part is not. So we can't consider it as part of the surface area of the cylinder, nor can we consider it as part of the surface area of the prism. So here we go. Let's do surface area 1 and surface area 2. So the surface area 1 plus surface area 2 is going to be our surface area total, but we kind of have to be smart about calculating these, correct? So surface area 1, it might be a good idea for you to draw out exactly in a net situation. Remember the net diagrams? To draw out what we're actually calculating. And for a cylinder, I don't know if we've actually done this in class before, but for a cylinder, if you're considering this piece and the wraparound piece, then what it looks like is a circle up top here. And really, this wraparound piece is a rectangle. Okay, so a circle and a rectangle. Now, can we find the surface area of this circle? Yes, we can. That is pi r squared, which is pi times 4 squared, which is 16 pi. And as a decimal, what's 16 pi as a decimal? 50.2655. Okay, confirm that as well. But this is what we're doing, the pieces. Now the surface area of the wraparound part of the cylinder. Okay, that's kind of little tough, isn't it? We have to find. It turns out to be a rectangle, right? And I know the height is 8 here. But how do I find this sort of length? Yes, thank you. It is the circumference of the circle, because this would wrap all the way around, right? It would wrap all the way around the circle, and so really it's the circumference of the circle. So, what's the formula for circumference again? Remember that? Yes, it's 2 times pi times r, so that's going to be this, times, so the area of this would be the length times the height, or 2 pi r times 8. Now, we're going to have 2 times pi times 4 is the radius times 8. So what's that? That's 64 pi, or in decimals, 64 pi, 201.0619. Okay, so we want to keep in mind this and this. That's the part of the surface area. And I don't calculate the underside here, do I? I do not calculate the underside because it is not exposed. Understand? So that's all we're going to do for surface area 1. That's this one, surface area 1. That's all we're going to kind of do. And now I'm going to focus on surface area 2 down here. So when calculating surface area 2, there are, surfaces that are pretty easy. They're exposed. That's the backside one. This is the other side one. So we've got, 14 times 12. That's the front side there. And we have actually 2 of those that we consider the backside, right? So 14 times 12 times 2. We also have 8 times 12 times 2. So I'm going to add to that 8 times 12 times 2, and those are the 2 sides. So I know that's one side there. I know this diagram's getting a bit messy here, sorry, but see the 2 sides there? And then this one is the front and back. And then we can calculate the bottom, which is 14 times 8. And I guess the question is, what do we do at the top? Any ideas? Yes. So let's do this. You're right. We'll subtract the area that is covered by this circle. So let's do the base, right, the bottom part. Let's do that times 2. But then let's take away this part of the, the area of the circle. So then we're going to minus the area of the circle that's covered up. Okay, I can't stress that enough. And this diagram is really, busy now. But you guys see that, I think, right? There's the top, and then we have to subtract this away because that's not covered. Or, that's not exposed, it's covered. Okay, so if you do kind of this piece and this piece and this piece and this piece, maybe you'll make fewer mistakes instead of typing all this in your calculator all at once. You never know what happens, or you might miss a bracket and you're totally messed up. So you add all this together, and what do you get? Okay, so yeah, this 192, that was an error there, so we fixed that. And so if we add all this stuff up, what do we get? So we add those up on the calculator and subtract that top part, and we get 701, 0.7345. Now that's surface area 2. So the final step is to combine surface area 1 and 2 to get the total. So remembering that we have to add this piece from surface 1 and this piece from surface 1. That's the circle and the wraparound part up there. And then add our total from the bottom part, and we'll get our total area. 953.06, and this is going to be feet squared. That should be your total surface area for this question. So each question is going to be a little bit different. You're going to have different shapes, and you'll have to keep in mind the overlap and make sure you take that into account.